Hey, ZKast from ZK Research here, and right now I'm at Mobile World Congress 2024 in Barcelona, Spain. Right now I'm in front of the AWS Next Level demonstration area where they have a bunch of fascinating use cases that show off Amazon Web Services technology and the world of mobile, cloud, and service providers. So let's go in, have a look around. I hope you enjoy the ZK tour. All right, I'm back. I'm in the telecommunications area here at Next Level, and I'm back with Young Jung. Just another quick intro on yourself.
Hi, my name is Young, Principal Solutions Architect, Specialist in 5G Core and RAN and IMS domain.
And you brought a friend with you this time, right? Subhash Talluri?
Yes, hi, I'm Subhash Talluri. I'm a Solutions Architect focusing on AI/ML, part of the go-to-market.
And I'm excited about this one because I think one of the industries that's really ripe for innovation with artificial intelligence is the telecommunications area. And you're going to show us how AI is being used in a telco core.
Yes. Last year during the MWC 23, we actually demonstrated how AWS can be leveraged for the disaster recovery case. It was fascinating use case because when customers use AWS for the disaster recovery network, they can use only the instances, only the amount of the network during the time when they need. So if they don't need it, then they can put it down and then power down, then they don't have to pay those instances and the resources. Yeah. So this is a great use case. AWS has a scalability, elasticity. Whenever they need it, they turn on, and only that time, pay-as-you-go model AWS is providing.
So some cost savings,
yes,
but also some sustainability impact.
Exactly,
too, right?
Yes.
Yeah.
But the next question, when to turn it on and how to turn it on. That doesn't make any sense if somebody has to sit down there to monitor, watch the monitor to turn it on. So that led us to think about using AI/ML. So this project, we have worked together with LG Plus and Samsung to implement some forecast and the anomaly detection-based scaling system. And Subhash will kind of take an introduction for the three systems.
Okay, Subhash, let's see what you got here.
Yeah, so what we have is we are looking at the UPF network function and the data coming from that network function, such as throughput, session information, and call success ratios. So we use that information to design three systems here. One is a forecast system, which is predicting the anticipated traffic for the next 12 hours in 15-minute increments. And then we have a diagnostic system which is doing near real-time anomaly detection on the same KPI, monitoring the traffic pattern. So just to give you an example, what you see here is the blue line is the actual traffic. This is real production data from the customer. The other three lines are the lower and upper bound of the forecast. So that is what is expected. However, you can see that the time frame here is that of New Year's Eve. So we see a peak load right around
Happy New Year
when everyone is saying Happy New Year.
Yeah.
Correct. So what happens is our scaling system is initiating reserve capacity based on what is forecasted. And whenever there's a deviation that we observe from an anomaly standpoint, we override the forecast and do an instantaneous scaling based on the anomaly score. And once the peak goes down and the forecast system picks it up, we again come back to gradual scaling.
Okay.
So as a result, we are just simulating December 31 data is keep being injected to the systems right now running on AWS. Samsung 5G core network is running on AWS. We are uploading every 5 minutes about the KPI of the December 31. And based on the input of the December 31 KPIs, system is responding and increasing and decreasing the capacity of the network by itself. Nobody is sitting behind the wall and then increasing and decreasing the instance. Machine is doing for us, and this is the beauty of the AI/ML powers. And this is the one that we want to bring to the table as maybe next to future network, how it will be looking like. Instead of using human power, human labors, we can do this kind of simple jobs and maybe some forecasting jobs by the AI/ML power.
All right, thanks. All right, well, we're back here, and we're going to actually take a look at a pretty interesting use case. This is how a service provider, in this case TELUS, is using generative AI, right? So generative AI, of course, exploded last year with the release of ChatGPT. I haven't actually seen it used in telecommunications yet, so I'm excited to see this. And doing the demo is going to be Sudhir Shet. Do you want a quick intro on yourself?
My name is Sudhir Shet. Welcome. I'm a senior partner solution architect at Amazon.
So, and what are you showing here?
We are going to talk about some of the challenges that telco service providers are facing with having to deal with deploying large-scale network infrastructure and having troubles with their O&M activities, that are day-to-day O&M activities, and how they can use generative AI and one of our partner solutions to address these challenges.
All right, let's see what you got.
Sure. Some of the challenges that customers face today are with having to deal with massive infrastructure and investing on these upfront, building this thing with little to no scaling, and having to deal with doing manual scaling all by together, which means they are paying upfront. The total cost of ownership is high. The other set of challenges that the customer deal with are with having to deal with tedious manual operation and maintenance cycles, which means from identifying issues, getting through the troubleshooting steps, and to get to the resolutions. It can go anywhere from days to weeks to months. So these challenges we are addressing twofold. One of them, we have been working very closely with the cloud native IMS network provider, that is NG Voice, who we are deploying at TELUS. This vendor has deployed a cloud native IMS on AWS, leveraging all of the cloud native services that we have, and especially using all of the AWS cloud features like elasticity and scalability and so on.
And then there's no way to do that with legacy infrastructure, right?
Yes, absolutely.
But they really have a need to scale up and down.
Exactly, right? And other part of the solution is how we can use Gen AI based dashboards and chatbots possibly to do on-demand observability of the network, wherein a customer can use natural language questions to get to know the network better, or ask questions like, okay, show me what are the errors in the last 1 hour.
And then, so that obviates the need for having that really expensive, high-paid resource being the only one that can troubleshoot.
Specialized resources, in fact. Yes, exactly. And the other cool feature here is that you could also alert an O&M engineer about a critical event that is happening on the network with prescriptive information of what exactly is going on, how we could go about the troubleshooting steps and get to a root cause and then eventually fix the issue. That's the closed loop part here, where you alert the user, help him through the troubleshooting steps, and arrive at a fix and fix the issue as well. That's what the demo will focus on today.
Okay.
At a high level, we have two portions. One is the proactive closed loop that I mentioned, that we push an alert, we simulate an alert, and we push an alert all the way to the LLM agents. And in this case, we have identified an issue which is alerted to the Gen AI dashboard. Gen AI dashboard provides prescriptive information of what could be the issue and how we could go about checking the issue step by step.
Okay.
And then
the closed loop piece, that's important because it self-learns, right? It gets better over time. Yeah.
Correct. And here specifically, the O&M engineer could ask specific questions on like what is the status of a node or any other questions and so on, and these can be translated to specific APIs, and the response could be related, which help the O&M staff to get to the final root cause and so on. So eventually getting to a bottom of the issue and fixing the issue. So the other part of the demo is where they could also ask offline question, on-demand observability, where they could ask questions in natural language. Guys, give me the last 5 errors that you notice and so on, which is translated. Natural language queries are translated into SQL queries, which is retrieving this information from the database and presenting to the user.
Okay.
Yeah. This could be further enhanced to use cases like, okay, give me a pie chart of all the different error code types in the last 1 day and so on.
But if it's Gen AI, you could even ask it questions like, show me the 3 regions of my network that are performing the best, or something.
Sure, absolutely. Absolutely.
Yeah, and the key there is now it allows people just in natural language to be able to query things to do troubleshooting or optimization, where, again, you could never do that before, right?
Sure, absolutely. Yes, totally agree.
All right, well, thanks. That was fascinating to look at how Gen AI is now coming to a telco near you.
Thank you.
Okay, here I'm at the second station, the one titled Agriculture, and it looks like you're doing something with 5G and mobile core, and I'm here with Hadi Najadin,
Yes.
right? And just a quick introduction on yourself and what you're showing here.
Yeah, Hadi Najadin, Senior Solution Architect at Amazon Web Services, Telecom International Business Unit. So
And you're a return demo person, right? So you've done this before.
So yeah, we did it last year for a smart home. But yeah, for this demo, what we did, we designed a solution that really help farmers around how they can leverage technology to help solving their daily problems, because farmers have challenges around optimizing water usage, managing their crop health efficiently, or even efficiently use all those pesticide, herbicide without harming the environment. They require technologies, but at the same time, these technologies require lots of integration and compatibility, because the sector is, again, is saturated with all these type of services, but there is no single unified provider of all these services that they can put all these solutions together.
And really, without technology, they're blind. Right? They're really guessing, and there's a ton of wastage in agriculture, from what I understand. Right.
Right.
Yeah.
And that's the same reason, because they really need that type of one unified platform that can give them access to all of these services. And what we found out was that telcos or telecom companies are uniquely positioned to deliver that service and that type of end-to-end journey to the farmers, because they own multiple pieces of this solution, and again, from there makes it easier. What we did was we built this demo around a marketplace that has all the catalogs and all the items relevant to the agriculture, powered by GenAI. Again, under the hood is all Amazon GenAI based services, such as Amazon Bedrock, Amazon Kendra, that provide all that extra context. So for farmers who are not that tech savvy and they just really need technology to help them, they can really leverage that GenAI that you're gonna see in the demo to help them around build that solution and order it.
Well, I'm excited about this. Let's take a look at the demo.
Absolutely, yeah.
Okay.
So here's a landing page that the customer get. As I said, it's that unified marketplace powered by GenAI, and the engine provider is Beyond Now that provides that. And this is where the farmer start getting to each of the products. But the first thing that they get is getting this GenAI chatbot agent, which help them around identifying the solution they need based on the problem. In this case, the farmer says, I have this weeding problem, and again chooses the weeding package that the GenAI recommended, and now that wants to see, okay, what more this system can provide. So the farmer identifies its farm area in on the cart, and from there, as soon as it does that, the area information gets populated. But again, the farmer still needs help about other parts of this items in this cart. What happens here, he clicks on that AI assistant, and the AI assistant, by reading the farm size, start providing recommendations around, okay, how many drones you need, or how many sensors you would need, or weather stations. And from there, so the farmers start having conversation about, okay, tell me more about this smart weeding solution, or how many sensors do you think I should have for this farm with this size? And again, everything gets recommended by the chatbot agent by having, again, observability into all of the catalog items. But what happens here is that this solution requires deployment of multiple services. In this case, the farmer needs a connectivity at the farm. So that would require a 5G slice or a 5G network at the farm.
That's why it's really a perfect opportunity for a company like TELUS service provider, because it's tied to the network service.
Absolutely.
Yeah.
And again, on top of that, also requires deployment of a mobile edge compute, something like this mobile edge compute device, as you can see, like an Outpost or a Snowball Edge. And on top of that, it requires deployment of a container orchestrator engine. In this case, we partner with Red Hat, which doing that job. And again, all of these deployments has to be done by orchestrator engine. In this case, we have partnership and leverage the use of Symphonica by Intraway, which actually a no-code orchestration and activation engine, which take responsibility of orchestrating deployment of the 5G slice, the mobile edge compute, the Red Hat OpenShift container manager on top of it, as well as the containerized application that is going to do the image analysis of the farm, which then provide which areas that require weed to be removed and eliminated. So as we move forward the rest, here's the order submitted to Symphonica to deploy all the components. Here, as you can see, the slice deployment takes place, the MEC deployment, and all those IoT sensors that need to be deployed also start getting deployed. And as you can see, all this process is completely orchestrated. The whole system is based on AWS services. It's a scalable architecture that can be deployed based on any type of a scale and demand that needed, which is again something that is supported for a telecommunication-based workloads. Here again, what happened here now, again, there is a tight integration between Symphonica and Red Hat OpenShift. So now the pieces of the deployment that requires deployment of containerized app is going to take place by Red Hat. So here we're leveraging a TMF open APIs that make really communication between all these different solution components easier and happen everything.
So typically it would be hard for a farmer to probably put all these things together themselves. But you've done all the pre-integration.
Right. Yes. This demo has worked, and as you can see, everything is happening live here. And on top of that, we're also leveraging a partnership from one of our partners, EPAM, who built this image analytics application for the edge. That again, Red Hat is going to deploy it at the edge on the MEC, which we'll touch base on it shortly as part of the demo. So this goes through this again. This is again
Symphonica.
This is Symphonica providing you a dashboard around to the network operator, what's really happening at the back end. And as we move forward, you're going to see that now the order is completed. The customer gets the thank you message as you can see here. And again, imagine now everything gets deployed and provided. So here's again, what we did was also, again, the telcos also want to make sure that the farmer also has a real-time view of the farm, right? Because farmers have dealing with amounts of or vast fields of farm, right? And again, there are lots of information happening. So what happened here that now we have sent the drones up. The drones took the image of the farm, and again, putting all those images together, and again through this portal, the images put together and
it creates
an
actual
3D model of
twin.
the farm.
Yep.
This is an actual farm north of Calgary that we did this demo on, and the sensors provide sending real-time information of the farm into the dashboard. So now the farmer has one single view of the whole farm, knowing what's really happening, and on top of that, this dashboard also is equipped and powered by a chatbot agent, because now all this census data is put on top of, or as a context on top of those through the RAG model to the LLMs or large language models, again hosted by Amazon Bedrock. Basically in this case we're using Kendra as a vector database, as well as the Amazon Bedrock Cloud Anthropic as the LLM.
Yep.
This is something again we're built together with our partner at EPAM for building this chatbot agent, as well as the images that, as you can see, because the customer or the farmer subscribed to the smart weeding sessions, subscribe to a smart weeding subscribe to a smart weeding service. As part of the smart weeding service, the drones go up, and once they go and start taking image, they're taking multiple images of the farm. All these images get together, create this concept called ortho image or ortho photo. And on top of that, they start running analytics on the image on the edge, and then identify the areas that need weed by doing computer vision analytics. Again, created by our partner EPAM. And again, this information is fed to the drone orchestrator, which identifies the flight path. This is something that a company that can help us with, that helps us here with, is called Unmanned Life. It's a drone orchestrator company. And from there, again, the flight paths of the drones have been identified. Coming back here, as you can see, a drone was used, an actual drone was used. As it's a sprayer drone, we use artificial dye to put in the drone for spraying. So for us in order to make the spraying area visible, here's again one sample, a spraying area. And again, we put some objects to just show how precise the spraying can be. And here's some samples. And as you can see also, this dashboard also can be enabled with live feed of the farm. So now if the farmers subscribe to the live feed or monitoring service of the farm, here's again the sample, a live feed of the data that can be provided in the dashboard. Here we use the service called KVS. Kinesis Windows System Service, part of the AWS, and that's basically what the farmer gets.
Okay. All right, Hadi, well, that was a fascinating demo. A lot of really interesting technology. We had GenAI, we had Edge, we had 5G, and I think one of the things he answered that I had a question coming at the Mobile World Congress is, what are those services that telcos could monetize to help them raise their average revenue per customer? And it certainly seems like an interesting one. So
yeah, absolutely.
So thank you.
Happy to help.
Thanks.
I appreciate it.
Bye. All right, well, that was a quick look at 5 of the 23 demos in the AWS Next Level area. That was a great look at how 5G, generative AI, non-generative AI, and cloud are all being used to transform different industries. So hope you enjoyed the ZK tour, and I'll see you next time on my next video.